Hello everyone, welcome to Chalkboard, where maths is taught the easy way. Today, we are learning the topic factorization. We will look at the idea of factorization, the concept of factorization, and also how factorization is done. I will urge each and every one of you to pay attention to what we are about to learn today. And if you have any question, if you have any topic you want us to learn together, I'll urge you to drop it in the comment section below. Now let's get to the book. I went to the market last time to buy some food stuff. So I approached woman 1 to buy some food stuff from her. So woman 1 sells pepper. She sells tomato. She sells ginger. And he also sells okra. I bought some of these things that she sells and I go to the next woman, that is woman 2. Now when I approach woman 2, I also find out that woman 2 was selling tomato. And she was also selling Maggi. She was selling pepper. And again, she was selling garlic. So I also bought some of these things and I left. Now later in the day, I sat myself down and I said, today when I went to the market, I approached 2 women. The first one sells pepper, tomato, ginger, and okra. And the second woman also sells tomato, Maggi, pepper, and garlic. I find out that some things that these women were selling are common. Because I can see from woman 1's table that she's selling tomato and also selling pepper. And woman 2 also sells tomato and pepper. So which ones are the like ones? So that evening, I jotted these things down and I said, okay, woman 1 is selling pepper and woman 2 is also selling pepper. So they all sell pepper. Woman 1 is selling tomato and woman 2 is also selling what? Tomatoes. Now, if the tomato and pepper that they have in common, if we break them out, if we bring the tomato and the Maggi that they both sell, if we bring them out, what will be left with woman 1? We can still clearly that if tomato is tried out, pepper is tried out, and tomato is also tried out, woman 1 will be having ginger and okra. 2 will also be having Maggi and garlic for woman 2. So now, we brought the things that were in common out. Now, woman 1 has only ginger and okra, while woman 2 also have Maggi and garlic. Now, let's look here. The common ones were brought out. Now, if this tomato and pepper is again added to ginger and okra, we come back to get these things that woman 1 sells. So nothing has been done to them, or it has not changed. And if we add this tomato and pepper to Maggi and garlic, we come back to get what woman 2 also sells. So the idea of bringing common terms out or common things out is what is termed as factorization. Let's take another example. So I went to 2 shops. Now in the first shop, the shop seller sells garri. She sells sugar. She sells groundnut and also milk. And in the second shop, the seller sells garri and also sugar and nothing more. Now, between these 2 shops, we can clearly see that in shop 1, garri is in shop 1 and also in shop 2, so that those items are common. In shop 1, sugar is sold here, and at the same time, sugar is also sold here. So that is also common. Now listen, if we are to bring the common ones out, as we did with the women at the market, we will realize that nothing will be left here. So now let's see. So Gary is out, and also sugar is out. So now if Gary is out and sugar is out, what will be left with shop 1? I hope now you are guessing. What will be left with shop 1? Shop 1 will be left with granite and milk. And shop 2, nothing will be left here. So I can put 0 here for now. You see, with the first example, when we brought the tomato and the pepper out, we were still left with some items with the woman too. But this time, everything that is sold in shop 2 is brought out. So nothing will be left with shop 2. That's why we are bringing 0 here. But mind you, when we are dealing with numbers, 0 will not be here. And when we get there, I'll tell you why 0 can be there. Now let's take another example. I'll try the example. Now, shop 3. We have Milo. And we have milk. We also have sardine in shop 3. And in shop 4, we have bulb. We have cables. And we have sockets. Now, shop 3 has Milo, milk, and sardine. And shop 4, we have bulb, cables, and we also have sockets. Now listen. Now, if we compare shop 3 to shop 4, do we have some common items? No, we don't. Because the items sold in shop 3 are not sold in shop 4. So with this instance, we can't bring any element of these two shops out. Let me take it again. We don't have anything that is common in this shop and this shop. Because this is Milo, milk, and sardine. And this is bulb, cables, and what? Sockets. So we can't have anything that are common aside the start of the name. And we can't use that unless we have an item that belongs to this side. So with this one, we can't bring any item out. So if we have our bracket, we'll have nothing out here, but we'll still have our Milo, we'll still have our milk, and we'll still have our sardine for shop 3. And we'll have our bulb, we'll have our cables, and we have our socket for shop 4. So these are our 3 examples. Now let's work with some alphabets. We have AB and we have AC. If I compare AB to AC, which one is common? A is common because A belongs to this side and also A belongs to this side. So we can bring the A's outside. So I bring the A out. Now A is out. What will be left here? It's B. So I bring the B for this one. Now if I come to this side, A is already out. So what will be left here? C. I bring the C also out. Now in this side we have only B. And this side we have only C. And in math, bracket here means multiplication. So if I multiply this A with this B, if I multiply this A with this B, I'm coming back to AB. And if I multiply this A with this C, I'm coming back to AC. Now let's take alphabet with the signs or the symbols we use in math. Now we have AB plus AC, and as I said, we have a sign here, a mathematical symbol. Now let's begin. We want to bring the common ones out, and with this term AB and this term AC. Now in math we know, or math, if we have 1 plus 2, 1 is a term and 2 is a term. So we have 2 terms here. So if I call this a term, please try not to be confused. So this is a term and this is also another term. Now from this term here, we have AB, and from this term here, we have AC. And the most common ones are A. So the A can be brought out. So if I bring out A, and I bring my bracket sign, what will be left here? Now A is out. A is no more there. So what is left here? B. So B will be here. Now, I bring my sign, the addition sign, I bring it back here. Now, A is already out, so what will be left here? C. So I bring the C here. That will be my final answer. Because from here, if I multiply this by this, I'm getting AB. If I multiply this by this, I'm getting AC. Now let's look at these two examples. We have AC minus A. And we also have here AB plus CD. We are still factorizing. So now, with this one, now, which one is common in this term and this as well? We can see that A is here and A is also here. So A can be brought out. So I bring A out here. So C will be left, because if A is not there, C is here. So C will be left. Minus. Now, we brought this A out. You remember the example 2 with it. All the items in shop 2 were in shop 1. The same thing we have here. So all the items here, or all the letters here, that's A, is found here. So we brought that one out. So now what will be written here? And remember, we are dealing with multiplication. After we have our answer, if we multiply back, we have to get the question. Again, after we have our final answer, if we multiply the term outside with the term inside, we have to get back our question. So now, in maths, we know that 2 times 0 gives us 0. 3 times 0 gives us 0. 100 times 0 gives us 0. So it means that if we bring 0 here, if we multiply A by that 0, we are going to get 0. That will give us wrong answer. The same way as I continue here, A times 0 gives us 0. Any number of any alphabet multiplied with by 0 gives us 0. Now let's try 1. Let's try 1. 2 times 1. 3 times 1. A times 1. B times 1. 100 times 1. Now 2 times 1 gives us 2. 3 times 1 gives us 3. A times 1 gives us A. B times 1 gives us B. And 100 times 1 gives us 100. So it means that with this, it tells us that any number I multiply by 1, give me back the number. So now, I want a number that will come here. That if I multiply this A with that number, I'm going to get back to this. And from here, we have it here that A times 1 gives us what? A. So 1 comes here. It is also telling us that anytime we factorize and everything in one term comes out, everything in one term comes out, 1 will be left over there. Now let's take another example, a clear example like this. So we have CK plus K. Now we can see clearly that this term here is only one, that is K. And this term we have two of them, we have C and K. And the most common ones in CK and K is K. So those common one will come out, or that common one will come out. Now K is out, so what will be left here? We left C plus. Now we can also see clearly that all the term here was out or is out. So now if K is out, what will be left here? This place can be 0. Because if this is 0, if I multiply the K by 0, I'm going to get 0. That's why we have A times 0 gives us 0. And that will give us a wrong answer because of this multiplication. So the answer that has to come here is supposed to be 1. So that when we multiply the K by the 1, we get this. Now let's look at this question here. Now we have AB plus CD. Now, we are factorizing. We want a common one. So this is A and B, and this is C and D. Do we have anything common here? No, we don't. So we can't bring anything out. Like how we did for the third example, that's shop 3 and shop 4. So because we can't bring anything here, we still have our answer as our question. That's AB plus CD. Because nothing can be brought out. But we can't leave it like that. We have to have one outside here. So that if we multiply the 1 by AB, we are getting AB. We multiply the 1 by CD, we are getting CD. But remember, if the answer is 0, because we can't bring anything out, we choose to write 0 and AB comes here plus CD comes here. It means that if we multiply this 0 plus times AB, we are getting 0, which will not make our answer right. And if we multiply 0 by CD, we are also getting 0. But if the answer, if we bring 1 outside, because we can't factorize anything out, we bring 1 outside and we multiply. 1 times AB, give me back AB. Like what we did, A times 1 is A. So AB times 1 is also AB. And CD times 1 is also CD. So anytime you can't factorize anything out, you write the person again in the bracket and bring 1 outside. That's what you factorize from what is not common. Now we are adding numbers to the alphabet. Now, we will take it one after the other. Now, with 2x and 2sy, we can see that from the alphabet, there is nothing in common. From the alphabet, x and sy, there is nothing in common. This is x and this is s, so there's nothing in common. But the numbers, do you have something in common with the numbers? Now, let's see. Now, the simple way is, let's look for the factors of 2. The factors of 2 gives us 1 and 2. And the factors of 6 gives us 1, 2, 3, and 6 itself. Now, between the factors of 2 and the factors of 6, which ones are common? That will give us the common factors. So, you can see that 1 is here and 1 is here as well. 2 is here and 2 is here as well. So these are the common factors. And among these common factors, which one is the highest? The highest is what? 2. So that is highest common factor. So that is 2. So anytime we have numbers and alphabets, we take them one after the other, but we look for the highest common factor between these two numbers and factorize that one out. Again, anytime we have two numbers to work with some numbers to factorize, we look at the factors of the numbers. Then we come to the common factors of the numbers. Then we come to the highest common factor of the numbers and we bring that highest common factor out. So as we did over here, 2 is the highest common factor. So we bring 2 out. Now, from 2x, if 2 is out, what will be left here? It's only x. But if 2 is not there, we have only x. So x will be here. Now, coming to this side. Now, this is 6. And we have brought 2 out. It is simply like the number here divided by this number. Again, 2 is brought out. Now, these 2, the whole of these 2 was brought out. So x was left here. Now, the number here, we brought 2 out of this number. Some people were thinking the answer here before, but it's wrong. No. It simply also means that 6 divided by 2, and that will give us 3. Then we add our s and we add our y. And we close the bracket. So please, 4 will not be left here. Anytime you factorize and the number you are confused with what will be there, just divide the number by the number that is outside. Then you get what you have to be left there. You get what has to be left there. Let me take this question again. Now, we just saw here that our factorization was 2. So that highest common factor between them. So we brought the 2 out. Now x was left here. Now we come to this side. Now we are bringing 2 out of this out. It doesn't mean that 4 will be left. It's not subtraction. So it is simply 6 divided by these 2 outside here. So what will be left here? 6 divided by 2. Meaning that how many times will 2 go into 6? How many times will 2 go into 6? Or simply put, 2 times what will give me 6? 2 times what will give me 6? And that is what? 3. Then I add my s and my y. Now the factorization is complete. So we have 5p minus p squared. Another example, 5p minus p squared. Now, there is no number here. And we have 5 here. And we have p here and p here as well. The 2 here is not a whole number. So we can't do anything with this 2. It is a power. P squared. It's not a whole number. It's a power. So now, between these two terms, 5p and p squared, what is common? And the common one is what? P. So we bring our p out. Now our p is out from 5p, so what will be left? If p is not there, 5 will be left here. So we have my 5 here. Are we good? Now, I bring my sign subtraction. Now this p are 2. It's p, p. And I'm taking one of the p's out. So what will be left? With another p here like that. That is all. We have 7 here and we have 21 here. Can 7 go into 21? Yes, it can. If we look for the factors of 7, factors of 21, you can see that 7 can go into 21. Or 3 times 7 even gives us 21. So 7 can be brought out. So 7 is out. Now we have t here, also have t here. So t is also out. So we can see from here that the whole of this term is out. The whole of this term. Everything here, 7t is out. So if everything is out, remember from the example that we did with the alphabet, if everything is out, what will be left here? 1. Because everything here is out. Now let's come to this side. 7 times what gives me 21? That will be here. So 7 1 7. 7 2 14. 7 3 21. 7 3 21. So 3 will be here. And remember, t is already out here. This t is already out. So I can't bring any t again. Then my last, what I'll bring here is s. Because there is no s here. Now I'll close my bracket. So my final answer becomes 7t, bracket open, 1 minus 3s, bracket close. Let's take 2 more tries. 8c squared minus 4sp. Now, this is 8 and this is 4. We have c squared and we have sp. The alphabet, there's nothing to factorize because this is c and this is sp. There's nothing in common. But let's look at the numbers. Can 4 go into 8? Yes, 4 can go into 8. Even we are both even numbers, so something can be brought out. And 4 can also go into 8. So 4 will be brought out because 4 can go into 8. So 4 can be brought out. So what will be left here? 4 times what gives me 8? So 4 1 4. 4 2 8. 4 times 2 gives me 8. So 2 come here. So that if I multiply 4 times 2, I come back to my what? 8. So what will be left here? C squared. Then my subtraction sign will come. Now, the whole of this 4 is brought out. So what will be left here? If 4 is not here, what will be left here? It's s and p. So that will also come. S and p. Bracket close. So this will be our final answer. Let's take a last example on this. That one comes with 3 terms, 3 different terms. P squared plus pq minus 4p squared. Now, what are the common terms? The common terms are p, p, p. So that one will come out. So p will be brought out. Now, these p's here are 2. And one is out. So what will it? It's like this. It's like p and another p. So I'm taking one of the p's out. So what will it? To make another p again. So that p will be out. Will be inside the bracket here. Then our addition sign will come. Now we have p and q. And I have taken this p already out. So what will be left here? Q. Now I bring my subtraction sign and I come to this side. I have 4ps. Now p is out. So what will be left here? 4s. That will be our final answer. We can't factorize anything out from this expression again. Okay, thank you for watching Chalkboard today. Now I have some exercises for you. Kindly copy these exercises, solve them on your own. After that, take a snapshot of it. Take mommy's phone or take daddy's phone, take a snapshot of it, and tell mommy to send it to my mail. Remember to do it yourself. And if you have any problem, please drop it in the comment section below. And you can also send me a mail with your past problem. You can also send me through WhatsApp. My WhatsApp line is also on the screen. Thank you very much for watching. And also remember to subscribe to the channel, because your subscription will motivate me to do more videos for you. Subscribe and also tell someone to also subscribe. Thank you very much for watching Chalkboard. See you again next week. Until then, bye bye.